Good morning. Today we will study about ionization potential and electron affinity. What is ionization potential? What is electron affinity? We will see the definition, and then what are the factors affecting ionization potential? What are the factors affecting electron affinity? Okay. First we will see ionization. What is ionization? Removal of electron. For example, oxidation. Ionization is nothing but removal of electron or oxidation. What is electron affinity? It is electron affinity is the reduction process. Electron affinity is the reduction process. Addition of electron. Another thing is ionization potential. Ionization energy is an endothermic process. The energy supplied to remove an electron from the outermost valence cell. Here, the energy is released. See, it is an exothermic process. When electron is added, the energy is released. Okay, this is exothermic process, this is endothermic process. Okay, now let us define what is, it is defined as the amount of energy absorbed or the amount of energy supplied to remove an electron, from the outermost valence cell, in the neutral gaseous state atom, neutral gaseous atom to form univalent, to form monovalent cation. In the gaseous state. That is very important. So it is the amount of energy absorbed or supplied to remove an electron from the outermost valence cell of neutral gaseous atom to form monovalent gaseous ion. See, on losing one electron, 1s2, for example, Z equal to 3, 1s2, 2s1, and it becomes 1s2 helium doublet configuration, stable configuration. It becomes stable on losing one electron. That's why it loses one electron. Similarly, if you see sodium gas, 1s2 11, Z equal to 11, 1s2, 2s2, 2p6, 3s1. The 3s1 electron is lost. Therefore, 1s2, 2s2, 2p6, it is an octet configuration, helium, inert gas configuration. That's why sodium also loses one electron readily. Okay. Now, similarly here, it is in the case of electron affinity, it is defined as the amount of energy released. See, the amount of energy released when an electron is added to the outermost valence cell of an isolated atom in the gaseous state to form univalent anion. Okay. So it is the amount of energy released when an electron is added to the outermost valence cell of an isolated gaseous atom in its ground state, or in its lowest energy state. Okay, now what are the factors? Although it is oxidation, it is the reduction process, but both the factors affecting ionization potential and electron affinity are the same. Okay, so it is interesting. That's why I have compared the two. They have common behavior. For example, atomic size. If you see atomic size, on moving from top to bottom, on moving down in the group, the size increases. For example, lithium is small and this is very, very big. Okay, atomic size increases. Therefore, ionization potential decreases. Ionization potential decreases as atomic radius increases. Ionization potential decreases as atomic radius increases. It is because, for example, here, similarly here also, for electron affinity, the electron affinity is inversely proportional to atomic size. Here you see fluorine, chlorine, bromine, iodine, and as we go down in the group, the atomic radius increases, atomic size increases. Therefore, the distance between the nucleus and the outermost added electron is large. See, the distance between the nucleus, and therefore the nuclear pull, the nuclear attraction will be less on the added electron, because it is far away from the nucleus. Therefore, it has less tendency to accept an electron. Therefore, electron affinity decreases as we move down in the group. Okay. Similarly, ionization potential decreases. Here also, electron affinity decreases. Okay, remember that because of the reason. Next, effective nuclear charge. What is effective nuclear charge? Okay, so So the ionization potential is directly proportional to the effective nuclear charge. Okay, greater the effective nuclear charge, greater the nuclear pull. See, greater the effective nuclear charge, greater the nuclear pull on the electron, on the valence electron, on the added electron here. Therefore, ionization potential increases with the effective nuclear charge. For example, in period, in group we have seen, in the first case, group, in period, the nuclear charge increases. You see, effective nuclear charge increases from left to right. Nuclear charge is greater, therefore electron affinity also greater. Therefore, as I said earlier, the nuclear pull will be larger. The nuclear pull will be larger here. The nuclear pull will be smaller here. Therefore, there will be greater attraction. Therefore, electron affinity is high. And here, electron cannot be removed. See, as nuclear pull is greater because of effective nuclear charge, the ionization potential is greater. The ionization potential is greater. Okay, now let us see the third factor, screening effect or shielding effect. See, the intervening electrons shield the outermost valence electron. If the shielding effect is great, the valence electron can be easily removed. So, if there is a shielding effect, this shielding effect decreases the attractive force because the intervening electrons screens. Therefore, this screening effect decreases the attractive force between the nucleus and the added electron or the valence electron. Therefore, ionization potential decreases. Similarly, increasing screening effect decreases the electron affinity. Same factor here also, same thing. Okay. For example, there are several orbitals: s orbital, p orbital, d orbital, f orbital. Among the orbital, s orbital has the highest screening effect because it is spherically symmetrical. It will screen the electron. It will screen the outer electron very much. Whereas p orbital, d orbital, f orbitals, the lobes are diffused. For example, in the case of f orbital, the lobes are diffused. They cannot be sealed very much. We have seen earlier Lambda contraction, imperfect sealing by f orbital electron causes Lambda contraction. We have seen in the previous class. Therefore, screening effect increases, ionization potential decreases. Similarly here, shielding effect increases, it decreases the electron affinity. And next factor is penetration effect. Penetration effect is directly proportional to ionization potential and it is also directly proportional to electron affinity. For example, s orbital has greater penetration effect because s orbital is close to nucleus. Therefore, it is very difficult to remove s orbital electron than p orbital, than d orbital, than f orbital. Therefore, ionization potential is greater for s orbital electron. Ionization potential is greater for. Similarly, electron affinity is greater because added electron, if it goes to s orbital electron, then it will be attracted by the distance between the nucleus, the distance between the nucleus and the outermost, and the s orbital electron is less, whereas the distance between the nucleus and the f orbital electron is large. Okay, so distance from the nucleus increases in this order, penetration effect increases in this order. Okay. Next, electronic configuration. This factor is common for both. I have given here. You should also learn this. For example, half-filled orbitals and completely filled orbitals subsets are more stable. See, for example, nitrogen is equal to 7 to 1s2, 2s2, 2p3 according to Coulom's rule of maximum reducibility. There are 3 unpaired electrons. Okay, this is half-filled orbital. This is more stable. Therefore, ionization potential will be large. Ionization. Similarly, it won't accept electron. So less electron affinity because there's less tendency, no tendency to accept electron. Whereas neon, similarly neon, completely filled shell subset orbitals. For example, 1s2 10, 1s2 2s2, it is completely filled. Therefore, ionization potential will be high, and electron affinity is zero. Electron affinity is zero because there is no tendency to accept electron. Therefore, electron affinity value for inert gases, the electron affinity values are zero because they have completely filled orbitals, completely filled shells. So the ionization potential and electron affinity also depend on electronic configuration. Okay, so if you understand you can write any type of question asked in competitive examination. So please watch again. If you don't understand, there are several questions based on this. Okay, it will be little bit confusing because but they have although this is oxidation, this is reduction, but they have common factors affecting both. Okay, thank you for watching.